So if you're in the endgame already, you probably know that the ideal crit rate to crit damage ratio is 1 to 2. This video will briefly explain the mathematics behind why that is, and also briefly explain how attack percentage will fare against crit rate and crit damage. But do take note that knowing the content in this video is not particularly helpful for artifact farming because it is heavily RNG gated, and there are damage calculators out there that can do the job for you. Take this video as a grain of salt and we shall begin. So what are some parameters that can affect the average damage output for your DPS? There's attack, crit stats, various damage bonuses, talent multipliers, defense and resistance of the enemy, and the reaction and elemental mastery. Out of all of those factors, damage bonus will usually give your DPS the highest damage increase, and changing the defense and resistance of the enemy is not something that a DPS usually does. And finally, elemental mastery is not that useful when it comes to main DPS unless the team heavily relies on reactions like Vaporize Xiangling. For most DPSs though, attack and crits are more important. So let's focus on attack and crits alone. Assuming every other factor is constant, we are essentially trying to maximize this expression, where C is a constant accounting for the contribution of every other factor, and F is a function of attack, critical rate, and critical damage that describes how these three factors can affect the output. So what exactly is F in terms of attack, crit rate, and crit damage? To find the average damage output, we have to consider both the possibility where we do crit and do not crit. When we crit, our damage is proportional to attack times 1 plus crit damage, and if we don't crit, our damage is just proportional to attack, times 1. Now, following basic arithmetics, we'll get this. If you want to remember anything useful for Genshin Impact from this video, it is this expression. Say you have two ways of equipping artifacts in your characters that give everything else the same except for attack, crit rate, and crit damage. Then the way you equip artifacts that give the best DPS is the one that maximizes F. There is a limitation to the total stat increase you can get from artifacts. Let's first consider what it costs to get a stat increase. This table shows artifact substat rows. Considering only 5-star artifacts, every row into attack percent gives an average of 4.95% attack, and rows into critical rate and critical damage will give an average of 3.3% and 6.6% of stat increase respectively. This gives exactly 3 to 2 to 4 ratio of attack, critical rate, and critical damage. For the main stat, for the circlet of logo at least, it is the same ratio. So if we want 3% of attack, we can either sacrifice 2% of crit rate or 4% of crit damage, and vice versa, given that the total number of artifact rows is a constant. So let's find a way to represent the total number of rows. We know attack, crit rate, and crit damage gains are in the ratio of 3 to 2 to 4. So to standardize gains, we'll use attack over 3, crit rate over 2, and crit damage over 4. And when we find the sum of it, we define it to be a constant. And this constant is related to the total number of rows on these three stats. So, and can change depending on how lucky you are with your artifacts, but it should have a similar value for endgame players. And now we are calculating that given a certain number of rows, which distribution in attack and crit stats can maximize damage. So now we want to find the maximum of F under constraint equation G. Since attack in F is the same as base attack times attack percentage, it can also be expressed in attack percent. And now we can use Lagrange multipliers to solve for the maximum of F. To understand Lagrange multipliers, let's look at an example with two variables. This surface is the graph of f of x1 and x2. The circles on the graph are level curves. F is the same everywhere on the level curve. The arrows that are perpendicular to the level curves are called gradients. Gradient points to the direction where f increases the fastest. It's basically the steepest direction around a point for a graph. Then if we add a constraint equation, we'll get a curve where constraint equation G intersects with f. To maximize f with constraint G is equivalent to finding the point where the curve is the highest. At that point, the gradients of f and g should be pointing toward the same or opposite directions. If they are not, then by moving along the curve, we'll find a point where they are. And that point can potentially be the maximum or minimum of f. This also applies to three variables. We want to find a point where the gradient of f and g have the same or opposite directions. In other words, the gradient of f should be a multiple of the gradient of g. So how to find the gradient of f and g? Well, in multivariable calculus, the gradient of f is just a vector with components of the partial derivatives of the variables of f. And calculus tells us the gradient of f is actually this. X, Y, Z are just our variables, attack percent, crit rate, and crit damage. If you're interested in finding the gradient, I'll link some articles probably. Just needs a little bit of knowledge in single variable calculus in terms of just finding derivatives, but that's all you need. We can also find the gradient of g. It is a constant vector with components 1/3, 1/2, and 1/4. Recall that the gradient of f is a multiple of the gradient of g at local maximum. By setting each component in gradient f to be a multiple of each component in gradient g, we'll introduce an arbitrary constant lambda and get a system of equations. And here we can get 4 different equations. 3 of the equations are obtained by setting the gradient of f to be a multiple of the gradient of g. And also the base attack in f didn't just disappear. It's already accounted for by the constant lambda since it's an arbitrary constant. And finally, to find the local maximum of f with constraint equation g, of course x, y, and z have to satisfy constraint equation g. And we already set the value of g to n, and equation 1 has to hold true. We can use algebra to solve for the value of x, y, and z in terms of n. Feel free to pause the video and solve for this thing. But if you want to skip over some melancholic algebra, here are the answers. The x, y, and z we find represent the point where f is maximized. And f max is the maximum value of f that can be obtained with a given n. Alas, you've made it all the way here. Let us conclude what Lagrange multipliers have led us. First, the ideal crit rate and crit damage is always in the ratio of 1 to 2. We can make further observations by plotting the 3 stats against n. Lagrange multipliers only hold valid in the region from n equals 1.26 to n equals 1.75, which coincides with what most endgame DPSs will fall in. From the graph, we see that maintaining a certain level of attack percentage will be the best for DPS. This level is approximately 212 to 224% attack, so if you're an endgame player, you can invest in crit rate and crit damage to maintain a 1 to 2 ratio between them, while maintaining attack at around 212 to 224%. This effectively maximizes your average damage output. However, there's more to that. There are various other ways you can obtain attack percent or crit and crit damage from character abilities, and even resonance. This usually means diminishing returns of investing in those respective stats. In these cases, there are limitations to applying the ideal ratio. For example, it is pretty common for people to sacrifice attack percentage for elemental mastery or energy recharge on Xiangling. It's because Xiangling is often paired with Bennett, and Bennett will give her enough attack that elemental mastery and energy recharge is actually more efficient for Xiangling's DPS. The same can be said about gains in the crit stats. Cryo DPSs, for example, will need slightly less crit rate because they have access to cryo resonance as well as the powerful effects of Blizzard Strayer, both of which give a bunch of crit rate. Ideal ratio is meant to be a reference only. It may differ slightly from DPS to DPS. Also, there are various good ways to build a character without necessarily following the ideal ratio. Perhaps the true ideal ratio is the mathematics we learned on the way. Fellow Genshin and mathematics enjoyers, I'll see you on the next one. Goodbye.